Hello class, this lesson is on Unit 3, Standard 1, and this is a bit of a review, a continuation of review before Calculus, or before Calculus BC, and this unit is all about derivatives. In case you forgot about derivatives, just some vocabulary and some notation that you need to know. Differentiation is the name of finding the derivative, and derivative is what you get after you do differentiation. So you may be wondering, what is a derivative, or if you did it last year, what are you really doing? The derivative function describes how a function is changing at any instant, or another way that they call it is the instantaneous rate of change. How are they changing the rate, whether it's speed, velocity, at a particular moment? Another way that you need to know what the derivative is it's called the slope or tangent line, slope of the tangent line of a function. Okay. For notation, they call it f of x. For f of x, it's called f prime of x. In equation notation, they call it dy dx, or ddx of y. Okay, dy dx. So here's what the official definition of a derivative is. So say, for example, you should have this on your notes. Say, for example, we're going to have some, we want to find the slope. Let's just say we want to find the slope right there. At that point, I want to know how steep is that line. Well, one way you could find slope is I could pick 2 points. Say I pick this point and this point, and I draw a line. I'll do this in red. And if I find the slope of those 2 points, I kind of get the slope. Let me use a different color. I kind of find the slope at that green dot right there, but it's not particularly like the slope. So what if I picked, instead of using those 2 dots, what if I picked 2 dots that were closer? So let me erase this. What if I picked 2 dots that were closer? What if I picked this dot, and then did the slope formula? Then I get closer and closer to the slope as those dots get a little bit closer. So the slope is kind of like it, but not quite. So as you may see, or where I'm getting at is, as these dots get closer and closer to the actual dot, and I draw a slope line, I get closer and closer to the actual slope at that point. Okay. So this is what the definition of derivative is. Okay. So what you're basically doing is you're taking the slope formula. Okay, I'm taking this over this. Okay, if you remember the slope formula, slope is y2 minus y1 over x2 minus x1. Okay, so that's the slope formula. You should remember that, right? So instead of saying these 2 points, what if I took a point at, let me zoom in. What if I took a point at that blue line and, I have too many dots here. All right. What if I took a point at that line, or at that dot, and picked another point here and drew a line? Okay. Oops. What if I took those 2 points and drew a line? Okay. Kind of have the slope, but not quite. So what if I picked a point that was closer? Okay, even closer. And what if I picked a dot that was just right next to that dot and do the slope formula? Then you have the perfect slope at that point. Okay, so the definition of derivative is exactly the slope formula, but rewritten a different way. Let's call the point at which I want to find the slope, let's call that x. Okay, and that point that I want to make the slope formula with, let's call that delta x. Okay, like I just want to, I just want to make it a little bit closer than, I want to get closer and closer to that point. Okay, so the slope formula is, okay, where the derivative is f of x plus delta x. Okay, so this y value of x plus delta x minus f of x, okay, over delta x. Okay, so I'm saying this is the slope formula again. So I want the y value, like y2 minus y1 over x2 minus x1, or the difference between the 2 values. So I made a mistake. What I really should be saying is this right here, this distance right here, is delta x. Okay, so the slope formula again is f of x plus delta x, so this point right here, f of x plus delta x, y2. This one is y1, okay, over x2 minus x1, which is delta x, like the distance between the two. Okay, so that's the slope formula. All it is a slope formula. So if anybody asks you what is the derivative, it is the slope formula. The official definition of derivative, if you look down at your paper, is that slope formula as delta x gets closer and closer to 0. So as that distance gets closer and closer to 0, okay, I can't find it when it's 0. I can't measure a slope when the 2 points are exactly the same. But it gets closer and closer to 0, I will find the slope. I know it's very conceptual, maybe hard to understand, but again, it's something that you need to know for calculus. This is the long way to find the derivative. Obviously, there's the shortcuts that you've learned last year, but you also have to know the long way for the for the AP test. So I will teach you not so much about it. I'm not going to stress out about it because you're supposed to know the shortcuts. So I'm just going to do one example of doing this the long way. So here on the left, you have a function, and I want to find the derivative using the long way, or using the official definition. Okay, here's how you do it. First thing you do is you're going to write the official definition of a derivative, which is the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. And again, this is just the slope formula. That's where we got it. Now, how do we do this? Okay, the first part, this piece right here, means take your function and put x plus delta x inside it. Okay, so remember, here's my function, and all I'm going to do is put x plus delta x inside it. Okay, so this is 2x plus delta x squared minus x plus delta x. So do you see, all I did was take my function, all I did was take this function, and everywhere I saw x, I put x plus delta x instead. So this right here and this right here are exactly the same, just x plus delta x. Minus, and you see how it says f of x, so now all I'm just going to put in is f of x, which was given to us in the problem. So f of x, again, is 2x squared minus x. Okay? And then the bottom is delta x. Delta x, we don't know a delta x, we can't solve the delta x, we just leave delta x by itself. Okay? So now all we do is we're going to solve this, we're going to simplify this, just like a real limits problem. Which I forgot to mention at the very beginning when I do the real definition. If I plug in 0, I get 0 over 0, which again tells me I have to do something. Okay, so I did something. Now I'm going to multiply this out. I get 2 by FOIL. This is x squared plus 2x delta x plus delta x squared. Okay, just by FOIL. Here I get a minus x minus delta x. And here I get minus 2x squared plus x all over delta x. Okay, so all I did was multiply out or FOIL out this term right here and distributed the minus signs. Okay, now I'll multiply out this 2. I'm running out of space, so I'm just going to continue on down here. I'll multiply out this 2x squared plus 2x delta x plus 2, oh sorry, there should be 4, 2 delta x squared. And then I have a minus x minus delta x minus 2x squared plus x over delta x. So I know I did that really fast. All I did was repeat what I wrote up top. Now that you did that, all you're going to do is try to simplify or cross out or combine common terms. So this 2x squared crosses out with this minus 2x squared. This plus x crosses out with this minus x. Okay? And that's all I can cross out for now. So to rewrite this, I get 2x delta x plus 2 delta x squared minus delta x. Okay. If you do the official definition correctly, just to give you a shortcut or just to give you a hint of what you're trying to do, you should have a term or all terms with delta x in it, so you could cross out a delta x with the bottom. Okay. So what does that mean? I could factor out a delta x from the top. Okay, so all the terms at the top have a delta x, so I could cross them all out. So I could cross out the one from the bottom. Okay, so now I have 2x, just because I'm running out of space here, I have 2x plus 2 delta x minus 1. Now that I cross something out, remember this is a limits problem, the last thing you do is try plugging in the problem or plugging in the number again. Way back in the beginning, remember this problem is as limit as delta x goes to 0. So going back to my original problem, I'm going to do this as delta x goes to 0. If I plug in delta x equals 0, my answer is going to be 2x minus 1. Okay? And some of you are going to think this is crazy, but if I look at my original problem, oops. Oh, I messed up here. Haha. So remember here, remember this is supposed to be a 4x delta x, so 4x, and then that's 4x. It's 4x minus 1, okay? So this is what you think is really crazy. Remember the original problem was 2x squared minus x. If you remember from last year to find a derivative using the power rule, if I use the power rule, this becomes 4x minus 1 also. So you can also use a shortcut and find the derivative. But again, for the AP exam, you need to know how to do it the long way. It is a long and tedious process to which some people say, like, why can't I just use a shortcut? I agree. But it's one of the standards that you need to know for the AP exam. So that is the official definition of a derivative. Just to review, remember you need to know that the official definition came from the slope formula, and I try to make the slope formula with the dots get closer and closer together. When I do the problem, I use the official definition. I plug in x plus delta x everywhere I see x. I fill it all in. I multiply everything out. If I do everything correctly, I should have a numerator that has all delta x's. In doing so, the delta x's will cancel from top and bottom, and then I can plug in 0 and get an answer. So that is the official definition. Hope you understand. If you have any questions, again, you're going to put it in the quiz questions, or you could ask me in class when I see you. So take care and have a good day.